Hey folks, so this video is about how to do a chi-square test in Excel and gives it in the context of a social work program evaluation example. And as you have seen in some of my other videos, this human services data set is what we're using. It's kind of a hypothetical situation where you have a couple of up to 40, it looks like participants who are in some type of program. They've got information about them here as well as pre and post scores on self-efficacy and then satisfaction and days served. Now, what we want to do is maybe we want to say is there a relationship between gender and let's say our satisfaction score? And the satisfaction is, so basically it's kind of saying, do males and females respond differently based on satisfaction? And we can answer that using a chi-square. So to do that, we've got our observed values here. Usually when you do a chi-square, a good place to begin in Excel is to put together what's called a contingency table. And the contingency table or crosstabs is looking at what the relationship is between your variables of interest. Now you see here, I've got male and female, and here I've got sat greater than 4 and less than 4. So greater than or equal to 4 is, you're probably satisfied. Less than 4, you're probably not satisfied. And what you'll see here, though, is that my satisfaction score is currently set up from 1 to 5. And so we need to take that and make that more categorical. It's going to make it a little easier for us to do the analyses. Chi-square works real great with these categorical types of analyses. So I'm going to write equal sign under my cell K2 here. And what I want to do is I want to take this satisfaction score and change it from 1 through 5 to 0 and 1. 1 if you're greater than or equal to 4, 0 if you are less than 4. To do that, we can use the lovely Excel formula ifs for a certain criteria. I'll say ifs I2 is greater than or equal to 4, then put 1. And ifs I2 is less than 4, put a 0. And voila, that's a 1. To check to make sure it works, let's just do 3 or 4 rows here. You'll see 4, 5, and 4 are all 1s, and 3 is a 0. Looks like it's working. We'll drag it all the way down. Now, what we need to do now that we have this value is we need to put in here the number of males who meet the criteria of having a satisfaction of greater than 4 and less than 4, and so on and so forth. And to do that, we're going to use a lovely formula called count ifs equals count ifs, and we can count. And the first thing we're going to do is we're going to count in gender. So count ifs, we'll go D colon D. That identifies the entire column there. And then the criteria we're going to say is comma M5, which is male. So count all the males, which is in this criteria, in this column D. But we don't want to just count the males. We want to count the males who have a satisfaction score of greater than or equal to 4. And so what I can do here is do a comma, and I'll say from K to K. And I'll count those whose score is equal to comma 1. Right? And voila, we see that there are 8. And the nice thing is that I can actually drag this formula down and it will work because in this formula it changes to M6, which is female. So we have 8 males and 15 females who said a score was greater than or equal to 4. Then I can also copy this formula and bring it right over here and do the exact same thing. But I'm going to go in here and hit copy first. So that way it doesn't, let's try that one more time. Copy and paste. No, it's not working the way I want to. All right, copy the formulas. Over. There we go. Now I do need to change these because it shifted all those columns over. There's another Excel trick to avoid that, but we won't worry about that for right now. Let's change them back to D to D. And then here we're going to have L, it's going to be K to K. And it's the exact same approach, only instead of N5 here, we want to do M5. And now here's the difference though, is that in K to K, well, we don't want the 1s, we want the 0s. So we're going to change that 1 to a 0. And basically what we're saying is count in column D the number of males whose satisfaction in this variable is 0, right? Or basically less than 4. So I'll go ahead and put that in and we'll see that's 8. And I'll drag it down. We'll see female here as well is 6. So you might say, hey, we had 15 females say they're satisfied and only 6 say not. And it was 8 and 8 for males. Maybe there is a relationship here. Maybe the females are more likely to be satisfied. And the chi-square can help us say, well, is that likely to just happen due to chance? Or is that something that we can feel certain, hey, there's something really going on here? Now, to calculate our chi-squares, what we want to do first is to start putting together our row totals. And you can do that with just a simple summation. So here I'll do my row total is sum of n5 colon to n6, voila, 16. I can copy that down here and do my row totals. And then here I need to do my column totals. So I'm going to equal sum, and I'll say n5 colon n6, voila, and I'll copy that over as well. And we have our whole nice little table here put together. Now you'll notice here that I haven't included non-binary, even though there's non-binary in the gender category. And that's because we only have 3 individuals who identify as non-binary. And for a chi-square test, you have to have your cell values higher than 5 for it to work out, or else you're sort of violating some of the assumptions. This puts one of our challenges into place when it comes to doing work with different subgroups and populations and using statistical tests that sometimes don't work in those particular situations. And so we have to be mindful of that as social work evaluators. We'll give you the example here of male and female, but we have to think of other ways to find ways to, I think, include those voices in the table too. So that for another conversation, but I wanted to point it out to you so that you're thinking about it. Now, we have our observed values, and observed values means this is what we saw in the program. This is what the data are telling from us from the program that we ran. But the expected values is a way of calculating, well, if you had 16 males and you had a certain distribution here, what would you expect the values of satisfaction to be? And what would the expected values be for female, et cetera? And to calculate that, there's a nice little way of doing that. You just do equals, and what you do is you take the total column here, in parentheses, this 16, we'll multiply it by the 23 down here, and we'll divide it by the total. Okay. And you get 9.9. So, we observed that 8 had a satisfaction score of greater than 4, but given all things equal, no relationship at all, we would have expected actually closer to 10 to say that they were greater than 4. And I'll do the same here. I'll go equals for satisfaction of less than 4. The same way, we're going to go equals the open parentheses 16. And this time, I'm going to multiply that by this number 14, right? And divide by the total. And so all things being equal, we would have expected 6, roughly around 6, to say that they were less than 4 satisfied, right? So that's how we can get a sense. We know that was 8 and 8. We would have expected 10 and 6, all things being equal. Now let's take a look at the same thing. It's the exact same formula and approach for females. So I'm going to hit the total, multiply that by the column total, close parentheses, divide it by the total. We get 13.1, and I'll do the same thing here for parentheses here. Multiply that by here and divide it by that. Okay, voila. And we got 15, we would have expected 13, and we had 6, we would have expected 7.9. So now we can take these expected values and start to do some analyses with them on comparing the observed versus the expected value and obtain a p-value. So I've written a chi-square p-value here, and we can hit equals, and we can take a look. Let's just look at the likelihood of greater than 8. So we actually don't even need this O column and this R column. We can look at this, the N column, which is going to be a focus, those greater than 4, and then also here, the Q column, which is the expected value. So let me erase that again. And I'll say for this one, we're going to use a neat little tool called the CHISQ.TEST, chi-square-test. And what we're going to do is we're going to select the expected values here. Basically N5 to N6. And then we're going to compare that to the expected values. And here's the expected range, which is Q5 to Q6. And we'll close the parentheses. What we see is that we get a chi-square value of 0.41. Now, as you saw, or as you may know, the p-value typically needs to be below 0.05 for us to be able to say that there's a relationship between these two variables. In this case, we see that it is 0.41. So we would conclude, well, there's really not a relationship between gender and the satisfaction scores, even though we saw that there were 15 males and only 15 females and only 8 males. When you actually look at the distribution, the fact that there are more females in the data set and that there's actually not that big of a difference from the mean, we couldn't really assume, based on the data that we see here, that there's definitely going to be a relationship here. But I do want to show you what a relationship might look like, what the numbers might look like for you to be able to show a relationship in a data set of a sample of this size. So let's pretend instead of 8 males saying having satisfaction of greater than 4, what if it was only 4, right? And then this would have gone up from 8 to 12 here, right? And what if for females, instead of it being 15, maybe it was 18, and this was only 3. Well, you see, if we change those numbers that way, and if that's what we actually saw in our observed data, again, the expected values all stay the same, what we see here is that the chi-square value, p-value, changes to 0.02. And so we see that if the data looked like that, we could have said, okay, yeah, there probably is a relationship between the variables of gender and satisfaction scores of greater than or equal to 4. And so you could say, hey, there's a relationship here. This is statistically significant. So I hope this has helped you as you have figured out how to do chi-squares. There's lots of applications for how you might do this. Anytime that you're working with categorical variables, things like gender and race, they're often used with some type of dependent variable as some outcome variable that is also dichotomous, something like yes or no, satisfied or not satisfied would be another example. Then you want to use the chi-square test. Hope this is helpful as you explore your own data using Excel.